Excellent. All right. Good morning, everybody. My name is Bert Steinman. I'm with Engineering Group. I'm a engineer and the water distribution specialist, overseeing or working with the surface water treatment plants within Michigan. I'm going to give you a brief overview of pumping systems at the water treatment plant level. This again is a kind of that 10,000 foot brief overview. We'll jump right into it.
Hey Bert, your audio
Yes.
is trailing a little on us. Just want to make sure you're in good proximity to your microphone and speaking at your microphone.
Okay. I hope this works a little bit better. All right. So again, we're dealing with a incompressible fluid, and we're going to talk about right off the bat pumps, right? The pumping systems, and the primary function of a pump, as we know, is to produce flow, right? Get that water moving, right? And as that interaction, the secondary function with that interaction of the flow in the water is the increase of pressure, right? We have an increase in pressure moving that flow of water through that network of pipe and that friction that we build up. Um, the pump's ability to increase pressure is only achieved by the fluid's resistance to being moved, kind of like what I was saying there. And flow and pressure are inversely related. As we have flow that goes up, the pressure will go down. As the flow goes down, the pressure will increase. Um, We know that the pumps, right, are an integral process, an integral part of the process at the treatment plant. Found in a number of locations throughout the treatment train at the plant. Um, Typically we start from a surface water plant, the low service pumps, right? The low service pumps are going to be pumping that raw water, that intake, that raw water. There's sludge pumps that are going to be at the treatment plant itself. And those are exactly what they sound. They're sludge pumps. They're moving those settled residuals, um, sludges, and the clarifiers that are settled out. And we're, you know, taking that sludge and pumping them through. We also have the surface wash pumps. That's using and utilizing the processed water for surface wash pumps. You've gone through the filtration, um, uh, the presentation here on backwash pumps. So we know when we backwash, right, we're backwashing those filter galleries and those filters. Those are pumps, right? We're backwashing those filter galleries. The transfer pumps, right? We're transferring that. Use the transfer pumps, right? We're taking that finished water and we're transferring that pump to a reservoir, usually a clear well. And then from the clear well, we'll go to high service pumps, right? And that's the high service pumps are taking that clear well water and distributing it out to the distribution system. Here we have this is a nice schematic here. We can see right up the top left corner we have an intake, right? Typically that's your raw water. Um, like we were talking about our low lift pump well, right? That's our low lifts. We're coming in. We have our preliminary treatment, usually a screening and a chlorine dosage there to our low lifts, right? To a reservoir, to a low lifts. Those low lifts there in turn push that water to the filter, the treatment plant, usually at a higher elevation. And through there, we'll go through another pre-chlorination. And we'll go through the coagulation and the flocculation of the water, right? The treatment. We'll perform that settling of the flock. Here also, we might have a line softening settlement. But once that settlement is done, this is where those sludge pumps would come in hand to take that sludge from the settled sediment basins and clear water, right, through the filtration. I'm sorry, through the sedimentation basins goes through our sand filtration. And we'll have different specific gravities, different materials, right? We'll go through that filtration process. And then from there, we'll go into that. That's our finished water. That's our clear well, finished water. And those that can be our low service pumps that might need to push that water to a clear well for storage and use. From there, from our finished clear water, we'll do a treatment again, a disinfection of a chlorine or a fluoridation. And from there, we go to our high lift pump stations, right? And those are the big pumps. Those are the pumps that are serving the community, right? We're pushing water up to the elevated towers. We're pushing water to the ground level reservoirs if there are, and we're pushing it to the homes. There was a great presentation earlier that Sally went through, talked about the elevated water storage, how they might offset those peak times, those fire flows, to help out on that high lift pump station. Now, we'll go back to the low service pumps, right? So here's a good picture also here. We have we can see seawater, or even in the Great Lakes, or a impoundment or reservoir or Great Lake. We have this engineered coarse sand in this example, right? And it's keeping that head pressure, and we're bringing that raw water into a well here, into an intake. Low service pumps are used to lift the source water to the head of the plant, right? That's our raw water. Here's our low lift service pump station, bring it in, just like it said, bringing it to the head of the plant. These pumps can either take suction directly from the source or from a well that is hydraulically connected to a source. And that's exactly what we're talking about. We've got that kind of that well situation here, or, like we're saying, they can pull a vacuum on there. So this is, again, the low service pump station, bringing that raw water to the head of the treatment plant. Low service pumps are typically controlled manually or by an operator. It's important to note that there are some facilities where SCADA, we've talked about that before, SCADA, which is the supervisory control and data acquisition system, right, is used to control the low service pumps based on the water levels at the plant. So they might, based on that water level, they're going to ramp up those pumps, those low service pumps, to bring in more raw water come into the treatment train. Again, these pump systems are employed on VFDs, variable frequency drives, that we can increase or decrease the pumping rates, right? Or with those pumps that will have various capacities, at that low service pump station. Low service pumps are often, definitely located off-site from the treatment plant, in proximity of the source water. Again, that impoundment, that Great Lake, that surface water intake, that raw water source. Yeah, so then so that's our low service pumps. Now we'll change gears. This is, again, just an overview of where you might see a sludge pump, right? So the sludge pumps are usually a diaphragm or a positive displacement pump. They're relatively small in size compared, we're talking 5, 10, 20 horsepower, sometimes, much smaller than that even, relative to the other plants, the pumps in the plant. These are controlled manually when these settled residuals, right, that clarifier are to be removed, right? Once they've settled out, that sludge is accumulated. We need to be able to take that sludge where it's settled, vacate it out, pump it out, put it into a place of treatment for a later date. Like they said, they take suction from the low point and the settling basins or the clarifiers. And here's a great picture. This is what you'll see in a sludge pump, right? You have the small pumping apparatus here with the electrical motor. Behind that guard will be your belt driven or your mechanical driven shaft. Surface wash pumps. Let's change gear. So the surface wash pumps, they're used to supply water pressure to filter surface. You're washing our filter surfaces, right? These surface wash pumps may not be needed if the system has sufficient pressure, right? If we're on a hydraulic grade on our treatment at the water treatment plant, there might be, like they're saying, adequate head pressure where you would need this, but not typically. Um, if these pumps are used to finish, these pumps use finished water, and they must have an RPZ, if to protect against the cross connection, right? We do not want any contamination of our finished water, right? So the cross connection program, cross connection elimination is essential there, right? We're taking a pump, we're boosting finished water, we're using it within the plant to spray and clean. Well, we need to make sure that pump repressurized water is not going back into that system. And this is a great example of a cross connection in that. So low capacity pumps are they're a low capacity pump relative to other plant pumps, and again, these are controlled manually. The biggest thing here is that cross connection, right? That RPZ to eliminate that backflow. So again, the backwash pumps. We'll change gear. Now we're into the backwash pumps, right? The pumps that are going to typically reverse that flow into the filter gallery. Again, used to reverse flow through the filter to clean solids from the media. The backwash pumps typically use the filtered or finished water, right? Or backflowing. We're turning those pumps on, we're reversing the flow, we're pushing through that media, we're getting all those organics, that filtered media that we're filtering out, suspended, pushed out, and dealt with and treated at a later phase. The backwash redundancy can be accomplished by multiple pumping units or by using a system pressure. Again, typically, like we go to the next bullet point, backwash pumps typically are located near the high service pump gallery that we'll talk about here soon. And backwash pumps are typically large in relation to other pumping units in the plant. They can be, typically controlled manually or on a schedule, but operator typically is in the vicinity watching, observing for any kind of shutdown, anything that might happen during that backwash, program. So then once we go through that filter gallery, right, we're taking our clear water, our finished water, and now we go through our transfer or our filter effluent pumps. All right. So the transfer pumps within the plant are used if the plant's hydraulic profile does not allow filtered water to flow by gravity to the plant storage tanks. So we're talking clear wells, reservoirs on site, water being stored to be pumped out to the distribution system. So it's going to take that pump, that's a transfer pump, to get those in those reservoirs. These can be individual filter effluent pumps or a confluence of pumps. Definitely one thing, what should not be happening is creating a negative pressure in the filter, right? So we're taking that finished water, we're pumping it into a clear well. We need to have design aspects in place where we cannot create that negative pressure on that filter. These are usually controlled automatically by a filter clear well levels, right? As the clear well level goes down, we need more water. These pumps are controlled by that SCADA system automatically. So now we have that finished water in our clear well ready to be distributed to the system, right? And so then typically what we're called, if it's not served by gravity at a high point in the system, we have a high service pump station, right? And this is that last pump station that's going to be, this is where your massive pumps are, right? These are the big 200, 100, 400, 500, 900 horsepower pump motors, right? Pushing this water. Again, this is typically the last stop before the finished water enters the distribution system, right? We're pumping water up to the towers. We're pumping water, if there are, pumping water out to the reservoirs and pumping water out to the customers as well. Typically, these pumps pull from a clear well which is either below them or next to them. This is a great example. Shows a good picture of a clear well, right? That would be underneath these vertical, looks to me like a vertical turbine high service pump here. And you can see the clear well, back to the left of the screen, we go through the serpentine entrance, right? We're creating that longer path of flow, right? That chlorine residual contact time. We're creating a good mixed flow. It's not a bad spot dilution or disinfection. We're going through the serpentine, getting a completely mixed chlorinated solution of water. And this is our clear well, right? This is finished water. This is going out to the distribution system. You can see the size of the massive vertical pumps here. This is where our big, massive, check valves, 20, you go through 24 up to 40-inch pipes, right? Ductile iron typically. This is where all your SCADA controls, not all, some of your pressure, your inputs are coming in from, your pressure inputs, your flow measuring devices. Your firm capacities are rated in this high service pump station. Here you can see these particular 960 horsepower pumps, right? These are the massive pumps, again, that are pushing out to the system, the high service pump station. These high service pump stations are typically controlled by the pressure or levels in the distribution system, right? Those are bringing all those sensors, those inputs into that SCADA system. That's, telling, these high pressure pumps, to ramp up, ramp down. To do this, they're typically on a variable frequency drive that in itself right there, the inputs are controlling the output of the pump. The controller schemes can vary widely depending on the type of distribution system. And in rare instances, high service pumps that are controlled manually can still be found out there. Not all, and you might look at a smaller system that might not have the developed SCADA network programming and control built in. So they're still controlled manually, to get those towers filled, get that pressure in the system and see that. Variable flow ranges are as necessary, right? Controlled through VFDs, the variable frequency drives, or maybe manually by operating, different size pumps. There might be 3 pumps, 2 might be the same size, 1 might be a smaller for that low flow if they're not using that SCADA system and VFDs. This will take some time to kind of digest here, but this is a P&ID program, instrument device, more or less for inputs and outputs on maybe a controls diagram. But what we're trying to get across here is the point of, placement in the system, right? So if we go from the left, we have our raw water intake, right? And like we were talking about, this is an overview to give the definitions of these different pumping systems that you might come across within the treatment plant, right? So raw water, low service pump station, right? That's what's controlling, that's what's pulling our raw water up to the head of the plant. So we go from our low service, now we're coming up to the head of the plant. This particular plant looks like it has 3 trains of treatment, right? So we go into these 3 trains, which could be the rapid mix and the maybe a lime softening. This is your clarifier with a rapid mix, your coagulation, your mixing's going on here with all 3 trains. Your flocculation is happening and settling out within these clarifiers. From there, we're going into this is your primary settling. Then we go into our secondary. We'll have another coagulation, separation, separating out. Let me back up. This is where in your clarifiers, your settled sediments, also sludge. These are where your sludge pumps would be. This is taking that sludge from that settled clarifier and putting it into some sort of tank storage for treatment, underground, usually away from site. So then we go to our secondary, like we were speaking about, more the coagulation, flocculation, settlement. Then we go to our filters, right? And so that once we enter our filters, we go to our filter beds, finished water is filtered out into the clear wells, filtered out into the clear wells. From there, we'll usually have a transfer pumps, right? So those are the big things, the low service pump, the sludge pumps, right? And then we go to our transfer pump stations. So we're transferring our pump, our clear water, our treated finished water to either a ground reservoir, clear well. I'm sorry, a ground reservoir from there. And then we go to our high service pump stations, right? From our high service, we're taking our ground reservoir water, pumping it up, providing that pressure out to the distribution system, which could be controlled by many aspects, usually, different pressure districts within the system, right? We're looking at lower elevations, we'll usually, see the highest pressure at that low elevation. So we need to make sure, right, by those inputs throughout the system, we're not over pressurizing those districts. And usually that's a control point on low elevations. High elevations too, we need to sustain the pressure there. So now we get into different districts, right? Pressure districts within the system, but more or less, again, this is the overview of the typical pumping systems you'll see at a treatment plant. And from there, I mean, that's again the big 10,000-foot aerial image of the different pumping systems you'll see at a treatment plant. Yeah, and from there we can go into any questions, and I think we can put them in the chat, and we can come back to a later time.